Hello guys, welcome back to the channel. So in this video, we're going to continue with our introduction to SQL series. So in this tutorial, we're going to start a new phase of our tutorial of our course. We're going to be going into database design. So we have, if you're new to the channel, again, if you're new to this series is all about introduction to database development, right? Introduction to SQL, right? So running different how to learn different SQL statements, basically everything to do with SQL from the very scratch. Okay, so in this we have learned the very basic, like how to write select statements, how we talk about different concepts like triggers, store procedures, views, and CTEs and all that. So right now moving into the database design and development. So if you're new to the channel and you're interested in learning all this, please kindly consider subscribing, liking this video, and sharing this content to anyone who you think might find it helpful. Okay, so let's jump into it. So the first we're going to be looking at in database design database design is a database design cycle. So different stages you go through in order to design a database. So there are mainly 5 different stages that you go through in the database design cycle. Okay, so the first one is the gathering of the requirements, and then you move into conceptual model design, data normalization, logical design, and finally actual physical database. Okay, so let's begin with the gathering of the requirements. So let's say that an organization calls you and they said, okay, we need help. We need your help to design a database. So you as a developer or as a programmer or data analyst or a data engineer, what you go ahead and do is not necessarily like a data analyst, like they don't really design databases, but yeah, you kind of get the idea, right? So the first thing you need to do is gather the different requirements. You need to understand the goals of the company or the organization. Why do they need a database? Why are they asking you to help them design a database? What are the purpose of the database to the organization? Identify the different stakeholders like the financial departments, the customers, anybody going to be using this database. Identify all the stakeholders, and then finally you need to understand the expectations of these different stakeholders. Okay, so this can be done through conducting interviews, interviewing the different people in different departments within the organization to understand their needs and how this database is going to be addressing those needs. So that's the gathering of the requirements. So from there you take notes on all the requirements the database need to have in order to satisfy the customer needs. So after that you move into conceptual data design phase. So in the conceptual data design phase, what you simply do is that's when you start trying to identify the different tables, or it's also called entities, right? The different tables are going to be in the database. You develop a relation between the different tables, how are they connected, and all that. And in this stage, you also do an initial, you draft an initial model, okay? And you move into the third stage, which is data normalization. And we'll look at data normalization later on. We won't be covering data normalization in depth, but we'll look at it just in a brief, okay? So data normalization helps you to reduce things like data integrity problems and data duplication problems. Don't worry about all this if you don't know what they mean. It's all fine. Okay, so again, that's what we're going to be covering in the upcoming videos. And then you move into the logical design phase. So the logical design phase, this is where you come up with different things like the position of your data sets. What are the different data sets you're going to be using for each of the columns that you have in your identified tables within the conceptual model design phase. You have identified the different tables, right? And each of the table has columns. So what are the columns? What does each column contains? What will each column contain? And all of that information. You do things like enforcement of referential integrity, constraint indexes. Don't worry about all this. We'll cover all of them in the upcoming videos. And then finally, we go into the actual database design, whereby you actually build the actual database schemas based on the previous work that you have done in the previous stages, like installing of maybe DBMS. Maybe you want to use MySQL, like you're using in this series, so you want to install MySQL, and then you begin to actually design your database, creating maybe ERDs in MySQL, and then finally converting the ERD to an actual database, and then importing data, and then testing out and making sure everything works as you expect it to, right? And you meet all the requirements that you have gathered in the requirements gathering phase. Okay, so that's basically a brief cycle of the brief introduction to the database design cycle. Okay, so let's assume that I have these two tables. So I've worked with the classical model database, and I picked these tables from there. Okay, so we have these two tables, the product line table and also the products table. So you can look at the product table. There are more fields, obviously. I just limited it to 4 fields. And you also have the product line table. So the product line table has product line, like the classic model cars, the motorcycles, things like that. And then you also have the text description, the HTML description, and then the image. And then finally move on to the product table, which has a different the product code, the name of the product line, the quantity in stock, and all that information. So look at this database. Why did the person who designed the class commander data models database that you have been using, why did he decide to put the database or place a database in this format? So why did he decide to do that? And it's a good design. Okay, so let's go ahead and try to answer this question. Is it a good design, or is it a good idea that he decided to place the products line in a different table and the products in a different table? Because you might think that, okay, these two are related and they should just be in a single table like this, right? So basically, I have the product code, the product name, the product line, the quantity in stock, and you have the HTML description and the text description. So basically, we just combine these two tables into one, just like this one. So why did the database designer of the class commander database design to have this split it into two different tables instead of having just one table like this? Okay, so just take a quick look at it and just pause the video and try to think about it a bit. But if you don't understand, don't worry about it much, because that's the whole point of this tutorial, to try to introduce you to those concepts. Okay. So looking at this database, you might say, okay, no, I like this database, actually a good database, but let's take a look at it more and let's try to figure out if this is really a good database. And the answer is simply, database has some issues, right? So the first one I can point out is data duplication and data integrity. Okay, what is data duplication? So if I go back to the table that we have, you can see the motorcycles, right? The product line, the motorcycles classical model. This is just duplication. So you can see duplicated. So if you have like 1 million records, then because you'll be duplicating this 10,000 times. That's a bad idea, right? We are just occupying memory for nothing, because it's just, you can just have this. We'll look at it more, but it's not a good idea to have all of this in the same database. And why is that a problem? Well, this brings us to data integrity. So imagine that a person wants to edit instead of having classic cars, he wants to say maybe classic model cars, right? So if you want to do that, and then we have 10,000 columns, and the user only goes and updates this specific row of this specific tuple, right? Updates only this column to classic model cars, and then the other ones remains to be classic cars, right? That's an issue in our database, because the data is not consistent, right? Here on this row it says that classic model cars, another row it says that classic cars, and all of them are referring to the same thing or the same line of products. Then that is an issue in our database, because if the data is not consistent throughout its lifetime. So that is called a data integrity problem. So that's a two main problems that you can easily spot out. Again, you might think, okay, well, if I want to update it, I'll just update it for all the columns that have classic models in their name. Well, that's also true. You can do that, but the issue is it takes time. Imagine you have 1 million records and you're trying to update, find each row that has classic cars and modify to classic model cars. That will take a long while to run that update, and it's not efficient as a database. Like imagine we have billions of records or millions of records, then you have to spend days and hours just running updates just to update classic cars to classic model cars, and that's not efficient, right? So good. So that's why we don't want data duplication, which can also lead to data integrity problem in case some parts of the data, some rows are updated while others are left unupdated. That's a problem. So we have looked at that already, and the data integrity. So what's data integrity? Data integrity is just overall accuracy and completeness and consistency of data throughout its lifetime. So you can see if you update one column and not update there's another column that has the same data and referring to the same thing, then you are not consistent and data is not being accurate and complete throughout its lifetime. So that is an integrity problem, right? Good. So again, as we've talked about the updating, do having duplicates is difficult to update, it is costly to run updates, right? So good. So what are the possible solutions that you might think of? So the possible solutions we might think of, let's just first of all discuss something called entity, and then we'll move on to the possible solution. So what's an entity? So I've mentioned an entity when we're talking about the database design lifecycle. An entity basically is a database. An entity in a database is a thing, a place, or an object that is independent of another. So for example, in this case, if I bring you back to these tables right here, these tables right here. So you can see this table, we have merged these two tables into one thing, but the product line and the product are two different entities, right? So they should be independent of each other, but in our case, we have merged them into one table, and that's giving us a problem of data duplication and data integrity problems, right? So that's an entity. It's just something that is independent of another. Okay. So for example, in our case, we have product being independent of the product line, right? Because these are two different things. So you can think of them as two different entities. So clearly we need to understand the best way to structure our database, right? Which is database design. So bringing you back to this table, this is just the design that we have currently in our classic model database, and this database have been throughout the whole series, right? So we have these two separate entities: the product line entity, and then the product table entity. So those are the two different entities. So we still have so separating them can help us to avoid some issues, right? So imagine that we have that now we have split our table into two parts: product line and then products table, because these are two different entities and are not in any way related with each are not in like are not dependent on each other, like yeah, something of that sort. So one thing you can notice is here we have the different columns and the different rows of each of these tables. Okay, so is this still a good design, or do you think that this is still a bad design? So you might be sitting down and thinking, okay, this is a bad design because number one, we still have data duplication. Imagine we have more rows, then another row can have motorcycles, and that's data duplication. And how are these two tables connected? So you might have all these questions, and you need answers, right? So let's try to look at all of this. Okay. So our problems that we still have is data duplication, which I mentioned earlier on, and we still have data integrity problems, because if you update one row and not update the other related row, then that's a problem in our database. So what's another possible solution? So another possible solution is to have the tables just the way they are, but you need to connect the two tables. So we need to find a field that is common between the two tables, and we use to connect the two tables. So for example, let's say that product line, right? So the product line, we might have something called product line. We might give this product line an ID. So you see here product line ID, and instead of our product line in our products table, instead of our product line column, we'll use the product line ID instead of the product line the actual name right here. So what we'll simply do, I have created another column which is called product line ID, and instead of the product line, instead of writing the product name of the product itself, I'm going to be writing the name of the product line itself. So instead of writing let's say this one right here, which is 1002, and 1002 is referring to the motorcycles. Okay, so instead of writing motorcycles, I'll write 1002. So I'll find a way to connect this. So you're going to use these columns to connect the two tables, right? So this is, we have another concept called primary keys and foreign keys. So primary key is used to uniquely identify each record in a table. So moving to our product line table, we have these keys right here, and you can see the product line ID are different values right here. So this is 1001, 1002, 1003. So for each of these new product line that we add, we have a different product line ID, which is going to be different. So you can use this to uniquely identify each product. So for example, once you know this product line and you move into our products table, and someone asks you what is the product code, product line of 1002, so you go back in and say 1002 is for motorcycle, so you can see, you can easily refer. So if you move here, you say 1001, 1001, you go in here, 1001 refers to classic models, classic cars, sorry. And if you go in here 1001 again, 1001 is classic cars. So you can see you have created a connection between the two. So the row that is used, the column, right, or yeah, the column that is uniquely used to identify each record instead of a table, we call it a primary key, right? Okay, so now what's a foreign key? A foreign key is a primary key from another entity, that is another entity used as an attribute in another entity to create a relation between the two. So you can see the relation between the two and how are they connected using the product line. So because if you know the product line from here, we can easily go and trace that information instead of our product line table, right? So that's basically this one right here is a foreign key, and this one right here is a primary key, because primary key is used uniquely to identify each record instead of a table, and then a foreign key is just a primary key that is used as another attribute instead of another table to refer back to the original table. Okay, so that's basically, so you can see in here the primary keys are unique for each row, but in here they can be duplicated. Okay, so that's the difference between a foreign key and a primary key. So having a relation between having a foreign key and a primary key, we can reduce data duplication, because for example, let's say I want to change this to a motorcycle, which is a problem that we had earlier on. I want to change classic cars to classic car models, right? If I want to change from classic cars to classic car models, what I can simply do in here is just, I'll just move into this table and change it to classic car models. That's all I have to do, because there's classic car models value is not used in here, right? Because this is just the only thing I'm using in here is just the primary key to it. So even if a person says 1001, it's still going to move down here, and if you update this, it's still going to be classic car models, right? So that's easy to run updates, because you just have to update this table, because the only way these two tables are connected is through use of these different keys. So If this is modified but this one stays the same, then you can easily trace it back. So the modifications don't really cause an issue. So that's the why you should use a primary key and a foreign key. So does it solve our problem? uh yeah, it's also a problem because number one, there's no data duplication, right? Then the names are not duplicated over and over again. And then finally, it's also a problem of data integrity, because if you want to run any updates, I can just change it in the product lines table, like I explained to you. I can change the classica model, classic cars to classica models only in the product lines table without having to change it in the products table. So it's easier to run updates. Okay, so it avoids the problem of data duplication and data integrity problems. So that's basically it. So data normalization is a process of organizing data in a database in such a way that data is protected against, okay, against things like data duplication, integrity and constraint. So that's basically what data normalization is. It's just a process of organizing your data in a database in such a way that it's protected against data duplication problems and data integrity problems. Okay, so that's basically it for this video. So one thing you have to notice is that in our classical models, we don't have anything as product ID, like in the product lines table. There's no such thing as product ID. I just get product line ID just to demonstrate you something, but in actuality, the product I think is called. Let me just scroll back in here. Okay, so let me just scroll back in here. So you can see the product line ID in an actual database of the classic models database. There's no this column called product ID. I just added this column to explain to you the concept of foreign keys and primary keys and how they can help to reduce to perform basically data normalization, which protects against data duplication and data integrity problems. So basically, in the actual database that we have that you have been using so far, the product line is actually used as the product as a primary key and the foreign key. That's why in this table, if I go back right here, that's why in this table we just have the classic model. So this is being used as a primary key and the foreign key. So it's used here as a primary key, and in here it's using as a foreign key. Okay, so yeah, that's basically it. And that's why in the initial database actually correct, because they have protected against data duplication and data integrity problems, and have normalized their data. So yeah, that's basically what I wanted you to take before I move into the next video. In the next video, um, we'll talk more about like the different product primary keys, foreign keys, data types, and other stuff. We'll go more into depth on it. Okay, so this is just an overview of database design concepts. Okay, so see you in the next video where we'll talk more about this in depth. Okay, so thanks for watching. If you're new to the channel, please kindly consider subscribing. That's one easy way you can simply help the channel. Subscribe to the YouTube channel, like the videos, comments, share the videos with anyone who you think might find it helpful. Again, if you want to help the channel further, or furthermore help me buy better equipment and make better videos, you can buy me coffee. The links will be in the description of the video. So thanks for watching, and see you in the next one. Keep safe.